Hello, everyone. My name is Gamanji, and currently I'm a principal open source engineer at Apple. I have joined Apple 4 years ago, and as part of this role, I'm bringing open source and cloud native expertise to different teams and products within Apple. As well, I'm part of the TUC, or Technical Oversight Committee within CNCF. Within this role, I'm joining 10 other champions within the industry, and we aim to provide a technical vision for the wider CNCF landscape. I have many other roles in the community, but I'm not going to focus on them today because I would like to focus on reverse engineering cloud native, and more specifically, focusing on interoperability and community. And to do so, first of all, I would like to focus on the emergence of interfaces. Here is where I would like to highlight how we go to a very expansive landscape with hundreds of tooling and hundreds of vendor solutions as well. Now, interoperability here is at the basis because we're going to embrace multiple solutions for the same problem space. And this is done through the appearance of interfaces. So I'm going to introduce the networking and runtime interface in addition to service mesh, storage, and cluster provisioning. Next, I would like to focus on community sustainability. Now, whilst the technology is the gravitational point of our ecosystem, none of it would be possible without a community around it. As such, here I'd like to highlight why it is important for us to scale at the same pace with technology evolution. And finally, I would like to leave you with a perspective, and more specifically, how cloud native influence different vendors, end users, and the wider industry in open source. However, before I move forward, I would like to look into how containers got globalized, and more specifically, look at the industry 15 to 17 years ago. Now, before I move forward with that, just a show of hands, how many of you are familiar with Kubernetes? Okay. How many of you are familiar with the kernel level of containers? Some. Okay, that's good. I'm just going to do an introduction on how we can run containers successfully. Now, to do so, we require two main primitives, cgroups and namespaces. Cgroups pretty much impose the limits of what a container can consume, such as CPU and memory. Namespaces, on the other side, imposes what the process can do, so it can interact with other processes, file mounts, networking systems, and so forth. However, these two primitives were available in Linux kernel since 2008, and containers got more popularized around the 2015 kind of gap. So we had a long gap of 7 years. And we have a natural question which emerges, why containers became popular much later? The answer to this question is that the technology became the competitive edge for every single organization out there. As an organization, it had to solve three main challenges, which are application complexity, fast deployments, and environment uniformity. Application complexity refers to the fact that we are operating in an infrastructure that has myriads of microservices that composes one product. Now, whilst this simplifies the development on those components, we still need to manage those at scale in production. Next, we have fast deployments, and this is an imperative nowadays. The faster you deploy, the more of a competitive edge you're going to have. And finally, we have the environment uniformity. And this refers to the fact on how we can minimize the delta between the local environment and production. Now, all of these tools or all of these challenges were solved quite successfully by the containers. And this actually contributed to the increased adoption of containers overall. Now, over time, we had multiple tools which were focused on execution of containers on different operating systems. And this is something that we have done at Apple as well. Now, during WWDC this year, we have open-sourced and introduced containers, which allows you to run containers on Linux containers on macOS. Now, this is fully written in Swift, so if you want more details on how containers run or the containerization framework, check out the GitHub repository or reach out to me. I'm more than happy to answer around that. Now, when it comes to containers, we have this standardization which was introduced. But we still have one challenge. How can we manage thousands of containers at scale? And this is where the container orchestrators were introduced. And 10 years ago, the container orchestrator framework space was very heavily diversified. We had tools such as Docker Swarm, Apache Mesos, CoreOS Fleet, Kubernetes, and all of them provided a viable solution to run containers at scale. However, Kubernetes took the lead in defining the principles of how to run these containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more importantly for its approach towards declarative configuration and automation. And we can see this in numbers when it comes to the technologies that were built around Kubernetes to extend its functionalities. such as support for different networking, observability, security systems, and many more. And this created what today we know as the cloud-native landscape, which resides under the CNCF umbrella. Now, this is the landscape that we, the TUC, are interacting with, and we are working with every single project individually to help them to reach the maximum maturity level. Now, currently within CNCF, we have more than 220 projects which are fully open sourced. And these are dispersed across 3 different levels of maturity. We have sandbox, incubated, and graduated projects. Sandbox projects refer to these greenfield ideas. They usually provide a solution for a niche problem space. Next, we're going to have incubated projects. And here we already see adoption in production. But more importantly, we see contributions from different organizations because we want to ensure that vendor neutrality in the development of the project. And finally, we have the graduated projects. And these projects refer to as the ones who cross the chasm. So pretty much they move from early majority to early adopters. These projects are here to stay, and they usually provide an industry standard within the area they operate in. Now, within CNCF, we have 146 projects at the moment, which are in sandbox. 36 are incubated and 32 are graduated. But I would also like to draw your attention towards the faint gray line at the top of the graph. This represents our archive projects, and I don't think we talk sufficiently about archival. Sometimes it is natural for some of the projects not to reach that momentum in contributorship or adoptership, and I think it's very important for the maintainers to take the lessons learned and redirect their energy either towards existing projects within the ecosystem or by creating a new tool and open sourcing that. And within the TUC, we focused more on assessing the project health, and some of them resulted in archival. So we're doing more archivals at the moment, and we have 20 projects with this status now. Now, this represents the worldview of the cloud-native landscape now. We have hundreds of tools which are fully open source, and we have hundreds of solutions from our vendors. However, the picture at the beginning was very different. More importantly, the community around Kubernetes was not always as flourishing and engaging, and we had to solve some very big challenges at the beginning. Now, Kubernetes is known for its ability to provide the environment for application execution while shrinking its footprint in the cluster. It is all about an efficient management of your resources. However, to reach the state of the art, multiple challenges required solutionizing, such as support for different networking and runtime systems. And this prompted with the appearance of 2 very important interfaces within our landscape, the container network interface and the container runtime interface. The CNI was introduced under the CNCF umbrella in 2017, while the CRI was introduced in Kubernetes 1.5 in its alpha release. Now, I would like to focus on these 2 interfaces because they were pivotal in the increased adoption rate for Kubernetes. And this is because we would be able to connect to our containers anywhere, and we'd be able to create our containers everywhere as well. So let's focus on networking first. Now, exploring the networking fabric within a Kubernetes cluster is quite a challenging task. Kubernetes is able to run workloads on a distributed amount of machines while preserving the connectivity and reachability to these workloads. As such, the networking topology is highly assertive, and it gravitates towards the idea that every single pod has a unique IP. Now, this networking topology dismisses the need for dynamic port allocation. However, it brings into light new challenges, such as how different pods, services, and users are able to connect to our application or pod. Now, the networking topology dictates that we can connect to our containers anywhere. As such, it was necessary to introduce some flexibility and integration of different networking systems at the time, which resulted with the appearance of the CNI that provides a network overlay for a cluster, but more importantly, it has 2 main operations, addition and deletion. It will pretty much make sure to attach an IP to the pod when it is created, and it will ensure to remove any resources when the pod is not going to be there anymore. Now, if we look within our landscape, we have a plethora of tools which provision this capability. And we all know about Flannel, which was kind of used to provide the network overlay for a cluster. If you want more fine-grained access control to your applications, you might use a tool such as Calico. And if you think about security, you can use a tool such as Cilium. But more importantly, here we already see the interoperability principle at play. We have multiple solutions within the same problem space, and the end user would be able to choose the tool that fits their requirements within their platform. Next, we have runtime. And here the story is slightly different. Now, at the beginning, the runtime capabilities were provisioned by Docker and Rocket. And the runtime component is pretty much the one who intercepts all of the calls from the kubelet, and it will ensure to create all of the pods with the right specifications on the machine. Now, at the beginning, the runtime component was very deeply integrated within the Kubernetes source code. And this presented two main challenges. The first one is a very high level, actually a very low velocity rate for new functionalities. If you develop a new functionality for your runtime, it will be deployed with the Kubernetes binaries. And this is a very lengthy process. It can take from at least 6 months to 1 year to have that feature in your production systems. The second challenge is a very high-level entry bar for new runtime providers. If you'd like to develop a new runtime, you'd require a very in-depth knowledge of the Kubernetes source code. And of course, this was not sustainable to move forward, and an interface was introduced. Now, the CRI provisions the capability of consuming runtime within a cluster, from which Docker and Rocket would be just some of the supported providers. Again, when we look within our ecosystem, we have many tools here, from which we have Cryo and Containerd being known for their industry standard to provide these capabilities. Also, there are runtimes which are supported for different cloud providers, which means we'll be able to create containers on those infrastructure providers by using their tools. But more importantly here, we can see an expansion rate of different tools within our ecosystem. Now, from this stage, the community focused more and more with the extensibility of Kubernetes rather than settling down to very specific tooling. And this is prompted with the appearance of new interfaces, some of which I would like to mention are the service mesh interface, storage, and cluster provisioning. Now, at this stage, with networking and runtime, we can create all containers everywhere, and we can reach our containers everywhere. So people focused on creating new functionalities, one of which is service mesh. Now, the service mesh interface was introduced during KubeCon Barcelona in 2019, and it democratizes the way to consume service mesh within your cluster. Now, this is a dedicated infrastructure layer that concerns itself with traffic sent across services during a request. And at the time, SMI was integrating with big tools such as Linkerd and Istio. But very important here, SMI is currently archived. Now, this is a very successful case of deduplication of work within our ecosystem because the SMI maintainers merge their efforts with Gateway API within Kubernetes. So, this is how we do archival successfully within our ecosystem. Next, we're going to have storage. And here, the story is very similar to runtime, meaning that the storage component was very deeply integrated within the Kubernetes source code. And we had the same challenges, same thing. We had a very low velocity rate for new functionality and a very high level entry bar for new storage providers. As such, it was necessary to extrapolate these from the Kubernetes repository and create an interface around it. And this is how CSI was introduced in Kubernetes 1.9 in its alpha release, and it moved to GA in 1.13. Now, this is one of the most developed areas within our ecosystem. We have more than 60 providers that allow you to consume storage outside of the cluster through this interface. And finally, we have cluster provisioning. And here the story is slightly different, mainly because when we talked about the networking, runtime, storage, and service mesh, all of these are within a cluster. Now, Cluster API takes the idea of interfaces a further step, and it redefines how you can create clusters everywhere in a unified manner. So it provides a set of APIs for cluster creation, deletion, and management, and of course, it has support for big cloud providers such as AWS, Azure, and GCP. Also has support for bare metal providers such as Tinkerbell and Metal-Free, and also Chinese providers if you have infrastructure there. Now, at this stage, we can see the fundamentals of how we reached a stage where we have so many tools within our ecosystem. And if you looked at the CNCF landscape, it's very overwhelming. But at the same time, whilst the technology is the gravitational point of our community, none of it would be possible without people around it, because we need people to not also adopt it, but to contribute and maintain these tools as well. As such, I would like to focus on the community sustainability as well. Now, from the beginning, the Kubernetes community operates on the principle that inclusive is better than exclusive. We create, build, and retain contributor communities through open governance and transparency. This is what pushes innovation forward and invites everyone to contribute. Now, if you'd like to get involved with any of the projects out there, I definitely encourage you to go to contribute.cncf.io, will be able to find guidelines and steps on how to get involved. However, I cannot stress this enough. Contributions are not limited to code. There are many ways for you to be an active member of the community. And it can be from participating in community meetings, or perhaps providing guidelines on how to navigate a part of the ecosystem, or perhaps you have feedback on how you use a tool in production. All of this is valuable work that helps us to move the innovation forward. And most of this work is led by our tags or technical advisory groups. Now, these are micro-communities that usually focus on a broader aspect within our ecosystem. And you'll be able to see that some of these tags are overlapping with the interfaces, such as networking, storage, we have observability, runtime, and many more. But what we have observed is that this is the state of the art from 10 years ago. We don't have as much innovation happening, for example, in the runtime space, or perhaps storage. All of this was very valuable work 10 years ago, but not necessarily now. We also realized within the TOC that a lot of work is led by the same people. So we are dealing with a challenge of renewing our leadership, and of course, leadership burnout within the tags. And within the TOC, we have kickstarted the tag reboot. Now, this aims to set our tags for success for the next decade of cloud native. If you'd like to know how we approach this from a community standpoint and a TOC standpoint, I definitely encourage you to go to issue 1527 on the TOC repo. But in a nutshell, some of the work that we're doing is to reduce the amount of tags from 8 to 5. And we're also introducing the notion of sub-projects and initiatives. Sub-projects are long-lived effort that will always be existing throughout the existence of our projects, because we'll always need feedback around how we can build a healthy community, and we always need a review of the projects, especially as they go through multiple milestones, such as sandbox, incubation, and graduation. And we also introduced the idea of initiatives. Now, these are very similar to working groups. These are short-lived ideas with very clear exit criteria. And currently, we identified the artificial intelligence white paper being one of the initiatives, with many more to be created. Now, another thing here is that currently, we have just elected leadership for the new tags. This is very much work in progress and very much recent. So if you'd like to get involved within any of the areas here, now is the time. So if you have any questions into how to get involved with these groups, I'm more than happy to help. All the information is publicly available on GitHub, and the community meetings also are publicly available. So you can join literally with no gatekeeping here. But another reason we have done the tag reboot is that we have identified within the TOC a lot of gaps within our ecosystem that were not addressed. And we're hoping by sharing these gaps with our community to shape some of the future trends or some of the movement within our ecosystem. Some of the three main challenges that I would like to share with you today are here. The first one is multi-cluster management and observability. This is still a challenge, even now after 10 years, mainly because we do not have a fully open source tool that focuses within this space. And this is the case especially if you have a cross-provider strategy. It's not just about creating your clusters, but maintaining and scale your clusters as well. When it comes to observability, this is still a challenge. Cross-provider strategy, having one unified dashboard, we don't have a tool there. So hopefully we're going to see more dynamic and movement within this space. Next, we have cost management and sustainability. Now, with an increased adoption of cloud-native architecture, we have more focus on the cost spending. However, we are equally responsible for our cost spending as much as for our carbon footprint. We really need to bring this element of sustainability to our infrastructure management. And again, we don't have tools here, and hopefully, one of the reasons we've done the reboot is to ensure that the tag environmental sustainability previously and tag observability would work together to produce any kind of solutions within this space. And finally, we have tooling around infrastructure provisioning and secret management. This has been a gap within our industry for many years. Again, I'm referring to fully open source tools that are fully managed by the community rather than one organization. So we are taking this chance to bring this up to the community one more time and hopefully initiate some momentum and some movement. And actually, when it comes to infrastructure provisioning, we at Apple have given it a shot. So we have open sourced Pickle. Now, Pickle helps us to scale the infrastructure management while bringing very rich validation capabilities. And it allows us to produce static configuration files in YAML, JSON, property lists, and so forth. Now, if you'd like, again, to find more about Pickle and the open source we do at Apple, reach out, or you can go to the GitHub. All of it is publicly available. Now, at this stage, we have these micro-communities. We are trying to arrange our community in ways that will set up for success. But at the same time, we still have all of our other community members which are using these tools. We need to maintain these tools. We have 200 tools, and we need people to maintain all of that. And this can be done usually through a culture of education, which helps us to scale at the same pace with technology growth. Now, when it comes to the culture of education, we have professional level certifications which are focusing here, such as CKD, CKA, and CKS, or pretty much certified application developer, certified Kubernetes application developer, administrator, and security specialist. Now, as I mentioned, these are professional level certification, meaning that you need production level experience in order to pass these exams. And we had feedback from our community saying that it's a too high level entry bar for new members. As such, we have created the KCNA, or Kubernetes and Cloud Native Associate Certification. This is a multiple choice entry-level exam that enables anyone with a passion within the space to get credentials. And following the same example, we have many other associate certifications focusing on security, observability, GitOps, you name it. We have a lot of certifications happening there. And as part of the same mission, I have created the Cloud Native Fundamentals course. Now, this is completely free, and you can find it on Udacity. But in this particular case, I'm focusing on bridging the gap between local development with Docker and running your application successfully within a cluster. But more importantly, as a community, we need to remember that we are working on software that really changes entire industries and sectors and how they approach infrastructure build-out and management. At the same time, however, we need to further diversify our governing boards, technical and advisory committees. As such, I would like to encourage everyone here to continue building a diverse community. We need to always strive to build this environment, nurturing environment, for the next generation of cloud-native practitioners to operate in. And I think that brings me to the conclusion today. Now, so far we focused on two main aspects of our ecosystem, technology and community. They cannot exist without each other. We looked into the emergence of interfaces and how the interoperability principle allowed us to create this expansive landscape. At the same time, we looked into some of the sustainability, community sustainability principles, and why it is important for us to scale at the same pace with technology evolution. And lastly, I would like to leave you with a perspective of how cloud native influence different areas within our space. Now, for the vendor community, cloud native translates into innovation. As a vendor, you do not have to create the interfaces anymore. It's already there. So you can use the interfaces to integrate with Kubernetes components and create your product on top of that, which will allow you to deliver value to your customers with minimal latency. For the end user community, cloud native translates into extensibility. It was never as easy as it is today to benchmark different tools with the same capability. As an end user, you'd be able to choose the tool for your infrastructure with minimal compromises. And finally, for the wider open source ecosystem, cloud native translates into innovation. We need to remember, again, the tooling that we're working with really changed entire industries and sectors, and in general, how we view and approach platform engineering. And all of this has been possible because cloud native ecosystem has been in constant transformation throughout the decade, and hopefully a decade more. And more importantly, it has created this expansive landscape for interoperability principle, but more importantly, encouraging us to build a healthy and sustainable community. And I think, here we go, without saying, we are hiring. Now, if you'd like to work for Apple, be it in Europe or in US, all our openings are available on jobs.apple.com. If you have any questions in regards to the recruitment process or the experience of working at Apple, I'm more than happy to answer. If you have any questions in regards to the talk, I can answer thereafter, or you can find me on social media such as Twitter and LinkedIn. This is Katie Gamanji, and I look forward to seeing how you can shape the cloud native ecosystem. Thank you, and enjoy the rest of the conference.